Okay, so these are just some more problems that I saw between the quiz and the homework that you guys were struggling with. So in the first part of the video, the first video, I should say, not the first part of this video, excuse me, we talked about just domain and range generally. So we have these kinds of questions where we had a continuous curve. So now we're going to look at graphs which are functions. It's a function because it passes the vertical line test, but it's a piecewise function because different pieces use different x's and follow different patterns. So when you're looking at a graph of a piecewise function, we're going to look at each piece and then try to put the pieces domains and the pieces ranges together, and sometimes it writes out kind of long and sometimes it will simplify. So let's start with domain. So this first curve, I'm going to do this based on the curve. So the first curve on the left starts here and it goes over to the right, 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 and then stops here. So the x's that I use start at -1 and go to 0. So that piece number 1, the domain for that piece would be starting at -1 and going up to 0. Now, look at the coordinates. This point here, -1, 5, is included on the graph, which means -1 as my domain number will be included. And then this point down here, 0, -5, is not included. So the domain value 0, remember domain is your firsts, so that domain value 0 is not included. Now let's look at the range of this first piece. So this first piece, the lowest it goes is -5, and then it goes up, 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 to +5. So the lowest it goes is -5, and the highest it goes is +5. Now, let's go back to the openness or closedness. So the point 0, -5 was not included, which means -5 is not part of your range for this piece. Now, there's no jumps or skips in this orange side, and so it stops at 5, and since -1, 5 was included, 5 is included in the range. Now let's look at the second piece. So the second piece, we're looking left to right. The second piece starts at 1, and it goes to the right, to the right, to the right until 2. So for the second piece, the domain will start at 1 and go to 2. Now we have to decide whether the 1 and 2 are included or not included. So here, 1, 4 was not included. So 1 is not included in the domain. And then this guy here, which is 2, -3, is also not included. So 2 will not be included in the domain for the second piece. Now let's look at the range for the second piece. So the second piece starts up at 4, and then it goes down, 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 down until -3. Now those guys were open. So the range for the second piece, lowest to highest, -3 up to +4. And those are both open because the end points of that piece were open. So this is not the answer to the question, but this is how you get the answer to the question. So we want to basically union these guys. So union means yours, mine, and ours. Intersection is just ours. But we're taking the union of these. So union is read kind of like or. So piece 1 says x is in between or equal to -1, but less than 0. So in between -1 and 0. Or x is between 1 and 2. Now, is there any overlap that I've like said twice? No. So the domain of my graph will be this weird looking interval, -1 to 0 union 1 to 2. But now let's take the union of the ranges. So this orange range says x is in between -5 and 5, or x is in between -3 and 4. Now, you could kind of see this from the graph that or is going to be yours, mine, and ours. So yours is in orange, and it's everything between -5 and 5, and mine is in yellow. It's everything between -3 and 4. So it turns out that all my stuff is some of your stuff. But that's okay. Nothing is skipped. So when I simplify this, my range will be from -5 to 5. So you always want to simplify your intervals. Sorry if you can hear my children laughing hysterically. Okay, let's try another one. So here's this graph. We're going to start with one piece and then we'll do the other piece. So for the first piece, this first piece here, I'll color it in orange. From left to right, it starts at -5 and it goes up to -4. So -5 to -4. Now, -5 is included, right? Because that point, -5, -2, is included. And then -4 was not included because this point, -4, 5, is not included. So 4 is not included in the domain. Now for range, we're looking lowest to highest. So this guy's lowest is -2. And it has all the numbers up till 5. Now -2 is included. But now 5 is not included because the only point on this orange part that has a 5 as its y was not included. So now let's do piece 2. So for this second piece, leftist to rightist is domain. So the leftist, this goes as -3, and then it goes up to -1. Now, -3, 0 is included. So -3 is included in the domain. And then it goes up to -1. And -1's point here is also included. -1, 3 is also included. So -1 is included in the domain for the second piece. Now the range for the second piece, lowest to highest, the lowest it goes is 0, and the highest it goes is 3. So the range for the second piece is 0 to 3, and those are included for the same reasons that the domain of piece 2 are included. So now that we've done that, let's union these guys together. So now, generally in domain, you're not going to have any overlap. Now think about that. The idea of something being a function is that each single x gets only one y. So basically, if something is used in the domain of the first piece, it won't also be used in the domain of the second piece. So there won't be any overlap, and we can just kind of write them next to each other. Closed -5 to open -4, union, closed -3 up to and including -1. But now for the range can have overlap, right? Because we didn't say that each single y only got one x. So now again, if you look at this picture in orange on the range, so on the y-axis, I'm saying you can go between -2 and 5. 5 was open. -2 was closed. And then the yellow range is like, hey, everything between 0 and 3. But when I put those together, like your stuff is orange, my stuff is black, what does our marriage have? It has everything from both orange and black, and we wouldn't write things twice. So we would say starting at -2 and going up to +5, not included. So these will be your domain and your range. Oops, let me undo that. This will be your domain and your range for your piecewise function. So I've got one more here, and again, I encourage you to pause the video and see if you get the same thing as me. I'm going to give just a little bit less explanation. So my first piece starts at -4 and goes and goes and goes to the right until it stops at 0. And then it starts back up again at 3 and it goes up to 4, but 4 is not included. So the domain of the entire graph is going to be -4 up to 0, both included, union, +3 up to 4, 4 was open. Now for the range, we're going lowest to highest. So the first piece, the lowest it goes is -2, and the highest it goes is 5. And everything in between there has a corresponding x value. But now the second piece starts at -1 and goes up to 2. But you can see those were already colored in. And even though this point for -1 is not included, this point over here is included. That was -1, -1. And so -1 does get covered in the range. So the range of the entire graph altogether is -2 up to 5. So now I also saw some questions about graphing lines that a couple people had some trouble with. So let me just remind you how to do this. There are a few ways to graph a line. So let's talk about those. You need 2 points, or you need a point and a slope. Now the slope you're going to count out. So if all else fails and you know nothing about the equation, you can figure out 2 points to graph. So if Alex doesn't say a specific way to do it, you can do it any way you want. So the most basic way is to pick x's and find the y's that go with them. So for example, if I pick x equals 0, then I have y plus 3 times 0 equals -2. So y plus 0, which is just y, equals -2, and 0, -2 will be one of the points on the graph. Now you can, again, pick any x you want. If you get a fraction, I'll show you how to graph that too. So if I pick x equals 1, then I have y plus 3 times 1 equals -2. So that tells me y plus 3 has to equal -2, which tells me y has to equal -5, because -5 plus 2 is, or sorry, -5 plus 3 is -2. So 1, -5 is on the graph. So now, to plot this or to draw this in Alex, the first thing I would use is the pencil or this plotting button to plot your 2 points. So when we plot 0, -2, we're here. And when we plot 1, -5, we're here. So when you draw those, I draw them as dots, but in Alex, it technically does a little X. So let me put an X so you'll see what it looks like. So you get 0, -2, and then 1, -5. Now I haven't drawn the graph, but I've plotted 2 points. So now the next thing you need to do is connect those points with a line. So you're going to use this button here, and it's going to turn into a hand, and you're going to put your hand on this X, 0, -2, and then you'll put the hand on 1, -5, and it will automatically draw the line. And it'll draw a perfect line, like not like my line, which is kind of bobo. Now I'm going to put arrows on the end because I don't have time to fill in the entire graph. All right, so graphing the line, when all else fails, pick an X, find the Y that goes with it, and then do that again. Especially if you get a fraction, use this button here to type in your coordinates. So like, let's say you picked y equals 0, right? So you have 0 plus 3x equals -2. So 3x equals -2, and x is -2/3. So the location -2/3, comma 0 is on the graph. But that's kind of hard to just click on. So if you use this button, it's like, hey, just type it in. You don't type decimals. You would type the fraction, -2/3, and then you would type 0, and it would plot the point for you here. Okay, so now let's talk about graphing the line using something specific. So if we want to graph the line, we could use slope and intercept. And what we'll do is we'll rearrange into y equals mx plus b form, and we'll plot the point and then count the slope. So I've got x minus y equals 3. Now what most people try to do here is move the x and keep the y on the left. And I don't really like that because the y has a minus with it. So I'm going to plus the y over. So I have x equals 3 plus y, and then to get y alone, I have to subtract 3 because it's a positive 3. And I get x minus 3 equals y. So if I write that, y equals 1x minus 3, -3 is your y-intercept. That's where your graph touches the y-axis. So there's one of my points. And again, you can use the pencil or you can use the plotter just to get the points on the graph before you try to actually graph it, the line. Because when you're moving the hand to try to graph the line, like your eyes are moving back and forth. And if you just slip your mouse just a tiny bit, you can get the problem wrong even though you knew what you were doing. So now the slope is 1. So now remember, slope is rise over run. So when there's no bottom, first of all, you put a 1. And then I like to put which way I'm counting. So since this is positive 1 over positive 1, I'll go up 1, right 1. And I'm going to do this from the point. So I'm going to start at this blue point and I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. Now you only have to plot one of these, right, as you use this button. So I would put the X there just so your mouse doesn't slip, like you can click properly. And then all you have to do is move your mouse up 1, right 1 and click, and it will draw this beautiful, perfectly straight line. So you've got two options of how you graph. You can graph using points, or you can graph using point slope. And now, again, to use point slope, you have to know how to count out a slope, and I just want to make sure that everybody knows how to do that. So remember, slope is rise over run. Rise is either up or down. Run is either left or right. Okay? So if I start here and I end here, I'm not even going to do any math. I'm just going to count. So I have to go up 1, up 2. So I went up 2. And then I have to go to the right. 1, 2, 3, 4, 5. So right 5. So I've got everything that I need, and I just have to attach my pluses and minuses. So on a y-axis, positive is up. So this is positive 2 over. And then on the x-axis, moving to the right is the positive direction, so positive 5. So the slope on this guy is positive 2 over 5. Now let's say that you decided to start over here and end over here. I generally always go from the leftist point to the rightist point, but again, you may not think exactly like me. So I'm going to go down 2, and then I'm going to go left 1, 2, 3, 4, 5. So down on the y-axis is negative, so I have negative 2 over, and then left on the down on the y-axis is negative, left on the x-axis is negative, so negative 5. Now negative divided by a negative makes a positive, so 2/5, and you see we got the same thing. So it doesn't matter which point you start at, but it matters when you connect with the left and the right, or the up and the down with the positives and the negatives. So let's try again. Again, I like to go from the leftist point to the rightist point. It literally doesn't matter. So I'm going to start here and I'm going to end here. Now I need to go right 1, 2, 3, 4, 5, just 5. So I went right 5 and I went 1, 2, 3 down. Now, even though I counted my right first and my down second, I still have to put the up-down number on top and the left-right number on bottom. So that 5 is from the bottom and the 3 is for the top. And now we have to attach our pluses and minuses. So on the y-axis, if you're moving down, that's the negative direction. And on the x-axis, if you're moving to the right, that's the positive direction. So when you have one positive and one negative, the whole thing is negative. So you could write this as negative 3/5, or you could write it as negative outside, and then 3/5. Or technically, 3 over -5 is also correct, but customarily we would write it one of these ways, with the negative on the top or the negative on the outside, not generally negative on the bottom. Okay, let's try 2 more. So if I start here and I end here, I have to go right 1, down 2, right 1, down 2. So up, down is my rise. So I've got down 2. And then left, right is my run, and I've got right 1. So we'll attach our pluses and minuses. Down is negative. Right is positive. So -2 divided by +1 is -2. All right, let's try this guy. So find the slope of the line. We're going to start here and we're going to end here. So we have to go up 1, 2, 3, 4, 5. So an up 5. And then to the right 2, right 2. So that's +5 over -2, or sorry, +2, which makes +5 halves. So now, if you think about the slope, like if the negatives and positives confuse you, always read your graph from the left to the right. Now, if I'm going from the left to the right, my graph is going from tall to low, from up to down. So that's going to be a negative slope because my graph is going down as I read the graph from the left to the right. Versus this other one, when I read from the left to the right, my graph is going up, 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 up. So that's positive. So you can tell the positive or the negativeness of a slope by what the picture looks like, but you should still also account for it when you're doing your counting.